Hey, welcome back. This is College Algebra. We're looking at 2.5, talking about zeros of polynomials. Okay, so we worked a little bit with polynomials before, and for the most part, they're fairly simple to factor. We want to factor more complicated polynomials and find their x-intercepts, basically, is what you're talking about when you're talking about zeros. So to help us along, we have what's called the rational zero theorem. And basically what this does is it gives us a hint as to what the possible zeros may be. Okay, so basically the possible zeros will be from the factors of the last term of the polynomial. So I'll just say factors of a sub 0 divided by factors of the leading term. Where if you've forgotten the definition of a polynomial, it would be something like f of x equals a sub n, x to the n, plus dot dot dot, all the way down to plus a sub 1 x plus a sub 0. Okay, so it's basically you could figure out kind of possible zeros by looking at this last guy and this first guy. And then what you do is kind of make ratios based on those two numbers. Okay, so let's take a look at it. It'll make more sense as we do an actual problem. That's the idea, though. Okay, so some examples then from the book. We have f of x equals x cubed plus 3x squared minus 6x minus 8. Okay, so nothing really matters except that last term and the first term, and there's the thing in front of the x cubed is a 1. So that's the stuff that matters. That's what we're looking at, and what we're going to do is consider all of the factors of 8, negative 8. So it's going to be 1 plus or minus 1. I'll just write 1. 2 divides into 8. Does 3? No. 4? Yes. 5? No. 6? No. 7? No. 8? Yes. Okay. And then all over anything that divides into 1. So the only thing that divides into 1 is 1. And then what we're going to do is kind of look at all the possible fractions. So we have 1 over 1, and that'll be one of our possible roots. So, and we want to consider both the plus and the negative versions. So we get plus minus 1, and then we have 2 over 1, which is the same as 2, so plus or minus 2. And then we have 4 over 1, so plus or minus 4. And then we have 8 over 1, so plus or minus 8. Okay? And that gives us some possible roots to try. And eventually we'll try putting those in and see if any of them work. Okay, let's get another example here. So this one so the problem is you can get a ton of possibilities if the polynomial is has enough terms. If the first and the last so if the first and the last numbers are composite, then you'll get a ton of possible zeros, which can be quite annoying. But anyways, let's look at this example. Minus 11x cubed minus 6x plus 8. Okay, so I guess this one's not so bad. So again, you list the factors of 8, the things that will divide into 8. Okay, so 1 goes in the 8, 2 goes in the 8, 4 goes in the 8, 8 goes in the 8, and then down below 1 goes in the 3, and then 3 goes in the 3. Okay. So this time for our possible zeros, we'll have 1 over 1, in other words, plus or minus 1. But then you also have to consider this other guy, 1 over 3. So plus or minus 1 over 3. And then you have 2 over 1, which is 2, so plus or minus 2. And then you have 2 over 3. Okay, so plus or minus 2/3. So you can see you're getting a ton of zeros that you have to basically go through and try until you find one that works. So 4 over 1, in other words, plus or minus 4, and then 4 over 3, so plus or minus 4/3, and then 8 over 1, so plus or minus 8, and then finally 8 over 3, so plus or minus 8/3. Okay. Okay. So once you have a list of these possible, and I love it when that thing starts popping up all the time. I have no idea why. But anyways, once you have a list of your possible zeros, then you're going to use synthetic division to see which one actually is a zero. Okay. So finding zeros. It's basically just a matter of trial and error, where you're checking whether or not it's a zero using synthetic division. In other words, when you substitute in the value, do you get out 0? And you could check that by seeing if you get a remainder of 0 in the synthetic division. Okay, so let's try one. Here's an example again from the book. We have f of x equals x cubed minus 2x squared minus 11x plus 12. First off, get the possible zeros. I'll just say PZ. Excuse me. So the things that divide into 12 are going to be plus minus 1, plus minus 2, plus minus 3, plus minus 4, no 5, plus minus 6, no 7, no 8, no 9, no 10, no 11, and then plus or minus 12. And then, the first term has a 1 on it, so it's just plus or minus 1 for the divisors. So the possible zeros, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. Okay, so you go in and usually you want to try the easier numbers, like try putting in 1, then try putting in 2, so save 12 for last. Okay, so we use synthetic division. So I'm going to try 1, and the polynomial 1, negative 2, the coefficients 1, negative 2, negative 11, and then 12. And I'm doing synthetic division. So bring down the 1. And then 1 times 1 goes here. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 11 plus negative 1 is negative 12. And then 1 times negative 12 is negative 12. And then 12 minus 12 is 0. Okay, so 0 remainder, that means this thing was a 0. And it then allows us to factor the original polynomial. So I could take this guy, and from this result, I could say x cubed minus 2x squared minus 11x plus 12 must be equal to, and now I'm going to borrow some of the material from the synthetic division. It must be equal to x squared minus x minus 12. So I just borrowed the coefficients from that red circle that I just did. And then times, now I borrow from the 1 that I'm circling in blue here. So you'll have x minus whatever that number in blue is. So x minus 1. Okay. And then if possible, I try to factor again. Okay, so I can now just use what I learned in pre-algebra or your previous class to hopefully factor that trinomial. So you use the quadratic formula if you need to, trial and error, so it has to be plus minus, and then I think we can get away with 4 and a 3 here. Okay, so once you factored it, then you could just read off the zeros. If you would rather, what you're doing is setting that factorization equal to 0, and then set the individual terms equal to 0. So x plus 3 equals 0. In other words, x equals negative 3. X minus 4 equals 0. In other words, x is 4. And then x minus 1 equals 0. And of course, that was one of our roots that we chose. That was the root we chose, x equals 1. And those are your zeros. And my math lab, they'll want you to write them in the set notation, so -3, 1, and 4. Okay. So you get the flavor, the idea. So you're using the rational zero theorem to enumerate a whole bunch of possible zeros. Then you're going to test the zeros using synthetic division. And once you find one that works, in other words, once you get a zero remainder, you can use that result to factor your polynomial. And then you hopefully can factor it even more using your techniques from your previous math classes. And then you can set it equal to 0 and you have your zeros. Okay, so it's just a kind of convoluted way of finding the zeros of a polynomial, the x-intercepts. Okay, let's try some more examples, or at least one example here. So f of x equals 2x cubed plus x squared minus 3x plus 1. Okay, so again, the possible zeros, the things that divide into 1 go in the numerator, and the things that divide into 2 go into the denominator. So in the numerator, the only things that divide into 1 are plus and minus 1. In the denominator, the only things that divide into 2 are plus and minus 1 and then plus or minus 2. Okay, so our possible zeros will just be 1, plus or minus 1, and then plus or minus 1/2. Okay, so let's start with, I don't really want to do the fractions, right? So let's start with 1. And my coefficient's 2, 1, -3. Don't forget if you need a placeholder to use placeholders. All right, so bring down the 2. 2 times 1 is 2, so we get a 3 here. 1 times 3 is 3. Get a 0 here, 0 here, and then 1. So no, that one didn't work because we have a 1 as a remainder. So let's try the -1. 2, 1, -3, 1. And here we go. So bring down the 2. 2 times -1 is -2, so this will be -1. That'll be on 1. So this is -2. That'll be 2. And no, it didn't work. Crud, right? Oh well. So now you have to start trying the fractions. So I'll try 1/2. Bring down the 2. 1/2 times 2 is 1. 1 plus 1 is 2. 1/2 times 2 is 1. -3 plus 1 is -2. 1/2 times -2 is -1. 1 plus -1 is 0. Okay, so I got it. Now it's a matter of factoring it completely. So again, the original polynomial 2x cubed plus x squared minus 3x plus 1. I can factor that now using this thing here. Right, so that will be 2x squared, just 1 degree less than the original, plus 2x minus 2 is one of the factors. And then from the 0, 1/2, you just go x minus whatever that thing is in blue I circled, right? So x minus 1/2. Okay, and then I try to continue factoring. I can factor a 2 out of that first trinomial, and I'll have x squared plus x minus 1 times x minus 1/2. At this point, you could try to go 2 times, and see if you can factor it without having to go to the quadratic. So it'd be like plus and minus. The trouble is it won't factor. Okay, so what you're going to have to do then is go to the quadratic formula. So you'll have from this polynomial x squared plus x minus 1. Here A is equal to 1, B is equal to 1, and C is equal to negative 1. Okay, so the quadratic plus or minus, negative B plus or minus the square root. So B is 1, so let's just put negative 1 there. Negative 1 plus or minus B squared, which is 1, minus 4 times A times C, divided by 2 times A. So that'll be negative 1 plus or minus the square root of 1 plus 4, which is 5, all over 2. And so we have two roots here, negative 1 plus root 5 over 2, and then negative 1 minus root 5 over 2. Okay? So if you wanted to write out the factored form, you would go minus the negative 1 plus root 5, and it looks pretty weird, you're probably not used to doing that, and then minus whatever the other root is, so minus 1 minus root 5 over 2. But ultimately the zeros are just right here and here, there's two of them, so if you set it equal to 0, then the solutions would be negative 1 plus root 5 all over 2, and then negative 1 minus root 5 all over 2, and then of course the 1/2 from our rational root theorem. Okay? And that would be the answer that they would want. Okay. Okay. It turns out that any polynomial can be broken down into a product of a bunch of linear factors. And by linear factors, I mean things of, so what is a linear factor? A linear factor is something of the form x minus c. Okay, so any polynomial, it turns out, and this is called the linear factorization theorem. It basically says any polynomial can be broken down into a bunch of these factors. So imagine just any polynomial, I'll just make one up. I don't know, f of x equals negative 3x to the 5th plus 2x to the 4th minus 15x cubed. I mean, you can make it at random. Minus x squared plus x minus 1. You can break that down into some leading term times x minus c1 times x minus c2 times x minus c3 times x minus c4 times x minus c5. Okay. So you just look at the exponent and you can break it down into 5 linear factors, sort of. Okay, so I say sort of because you know that there's going to be cases where that won't work, right, in the real numbers, right? So the sort of part is that the c's here may not necessarily be real numbers. Okay, so I'll just break that kind of as a warning. You know, it seems like, oh, that's a great thing, but the truth is the C sub, I'll just say i's, may be complex. And of course, they may not all be distinct. So C1 might equal to C2 or something. Okay. Okay. So some really high-powered theorems there in this section. Fundamental theorem of algebra is also in this section. I encourage you to go read it. Let's take a look at an example though. Okay. That's along these lines. So what they want you to do here is to find a third degree polynomial with real coefficients that has negative 3, and the imaginary number, the imaginary unit I as zeros. and f of 1 is equal to 8. Okay. So how are we going to do this? You're going to set it up first using that previous theorem here, the linear factorization theorem. So you know the form. If it's a third degree polynomial, it has to look like this. It has to look like a sub n, or we could just write a if you want for the leading coefficient. A times x minus a 0 times x minus a 0 times x minus a 0. Okay, so if it's third degree, you're going to need 3 of those linear factors. Okay? And then you're just going to put in, I mean, it's telling you it has some of the zeros right there. So in blue here, one of the zeros is -3. Okay, so I'm going to put -3 in here. One of the other zeros is I. Okay, so I'm going to put I in the next one. One side note is that if you have one imaginary, these complex numbers always occur in conjugates. What does that mean? That means if you know that I is one of the zeros, you'll also have -I as a 0. So just let me write that. Imaginary, let me put it in a different color. Imaginary or complex roots always occur in conjugates. So we will also have, in this case, -I as another root. So remember conjugates, how did that work? If you have the complex number 3 minus I, the conjugate is 3 plus I. Okay? If you have 2 plus 7I, the conjugate is 2 minus 7I. Okay, so those are conjugates, that's what I mean. Okay, so if you have I, then its conjugate is -I. And so we can finally then put this third guy in here like this. Okay. So we have a third degree polynomial, but the problem is now this leading coefficient, this a value. We need to figure out what the heck that is. And to figure that out, we're going to use this one last bit of information, that f of 1 is equal to 8. Okay. Okay. So first things first, I'm going to go ahead and simplify this a bit and then multiply it out probably. So I have x plus 3 times x minus I times x plus I. Okay. And then I have, I'm going to go ahead and FOIL. So I have x plus 3. Because these are conjugates, the middle term will cancel out. You'll have x squared minus I squared. So if you've forgotten, to the top over here, I squared is equal to -1. Okay? So you're going to have x squared minus I squared. I squared is equal to -1. So I'm going to replace I squared with, well, you guessed it, -1. So minus -1. And then minus -1 is plus 1. And then I'm going to FOIL out those two guys. So I'll have x cubed plus 3x squared plus x plus 3. Okay. I still need to get that a value. So I remind myself that, okay, f of 1 is equal to 8. That was that given information in yellow above. Okay. So how do I work this? So I'm going to put 8 in for the f of x part, and then put 1 in for x on the other side, and then solve for a. So I have 1 cubed plus 3 times 1 squared plus 1 plus 3. Okay. And then I have 8 equals a times 1 plus 3 plus 1 plus 3 is 4, of course. So 8 equals 8 a eventually, and then divide both sides by 8, and you get a is 1. Okay, so finally then I can put my third degree polynomial together. I just have to distribute 1 to every term. Of course, it's just going to give me back what I have. X cubed plus 3x squared plus x plus 3. Okay? Okay, so a bit tedious, but not exactly splitting the atom, so to speak. And you're going to be able to do this, okay? All right, so we'll cut the video short there, and I'll see you next time.